In the previous video, we have seen the structure of AVRO files and different data types in the schema. Now let us see how we can generate an AVRO file or how we can read an AVRO file using Java. Here is the schema we are going to use. This is a person schema. Person is a record. It has a namespace test.area. Namespace is nothing but it's a qualifier for the name. It's like a folder in a file system or a package in a Java. And it has the fields name, occupation, company, address, age, and address is an array. And address has address line, address type. Address type is a enum type. It can have one of the two values, either home or office. It can have city, postal code, and phone. Phone can be of two types, either null or a string value. We are saying default is null. If you are mentioning a default where a union is mentioned, then the default type should be the first type. Otherwise, the parser will throw an error. Here is the data that we are going to use to create our file. This is one person's information. Name of the person is test user. Then occupation is architect, and he is working in a company ABC. Age 34, and he has two addresses. Address 1, the home address, and address 2, the office address. And in office address, phone is given as null. Now let us look into the Java code where we create an AVRO file with this record and how we read an AVRO file. I am using a Maven project. Here in the form file, let us see the dependency required for AVRO creation. Only one dependency is added, that is the artifact AVRO, and the version I am using is 1.11.1. It has only one Java file. Here what we are doing is we are creating an AVRO file and we are reading the file that we have created. The out file location is given here. Then the data file, this is the JSON file what we have seen. The schema location, the schema is what we have seen here. First what we are doing is we are reading the schema file as into a string. Then we are passing it and converting it into the AVRO schema format. Then we are reading the JSON data. Since it's a JSON file, we are using the JSON decoder. We are mentioning the AVRO parser that it's a JSON data that is coming in. Use the JSON decoder to decode the data into the generated code. Then we have the datum reader. Datum reader is used to read data, parse it using the schema, and transform into in-memory object form. So datum reader is going to serialize or deserialize the data, and here we are reading the data into a generic record format. Here we are using a generic record, so we don't have to convert our schema into any Java POJO object. From this generic record, we can read data like this, person.get name. Same way, all the fields we can read this way. Here we are setting a different data to the field name. We have seen that in our data file, we have given the value as test user 1. That we are replacing with the value Jane. Then the datum writer is used to convert Java objects into an in-memory serialized format. It's a reverse of datum reader. Datum reader will deserialize the data into a object, and datum writer is going to convert the object into a serialized data. So here we are explicitly mentioning we are using JSON decoder. If you are not mentioning any decoder, then a binary decoder will be used, and usually we'll be using binary decoder. In the datum writer, we are saying that use the schema. This is the common schema that is used everywhere because we are reading and writing with the same schema data. Then we have the data file writer. This is used for writing the schema and the serialized data into a file. Here we are creating the datum writer with the schema and the file location, and we are appending our record. This is a generic record, and we are writing. If we have 10 records, we will go on appending to the same file. That's all, and it will write the AVRO file for us. Now let us see how it is read. Same process. It will have the datum reader, then it will read the file using the reader, and here you can see that it is going through each of the records, because one file can have multiple records. It's checking whether there is a record. As long as there is a record, loop through it. That's what we are saying here. And for each one, we are displaying the name, occupation, and address is an array. So that is assigned to a generic array, and we are looping through the array and displaying address line and phone. Now let us run this code. We can see that the data read from the file is test user1. When we read it, the value is changed to Jane, because we are putting, or we are replacing the value with the value Jane. This is the way an AVRO file is read or written. Here we have seen that we are not converting the schema into any POJO objects, but there's an option to do that as well in AVRO. Let us see that one. In this POM file, we have added a few extra things. One of it is the plugin. This plugin is for generating Java source code, and we have to, this is the source directory where we have to keep the schema file, and output, the Java code will be generated here in this location. Here you can see that I have placed the schema file here. Now let us generate the file. Generate sources, and successful. We can see here that a test.area package is created, and under that all the POJO objects are generated. We have the person, address, and address type. Address type is an ANM, that is why it created a separate class for that. Code is almost the same. Only difference is we are mentioning that read it as a person object instead of as a generic record. Other than that, not much difference is there. When we have a POJO object, we'll use the setter and getter methods. We are saying get name here instead of giving get and the name string. We are setting the name here. We are reading it the same way. We have the address as an array, so we'll get it as a list of addresses here instead of a generic array object. And we are looping through that one and displaying address line by saying get address line. It will create the same result as what we have seen before. Now what we are going to see is how to compress records in an AVRO file. For that, we have one more dependency here. There are multiple compression algorithms. One of it is Snappy. For Snappy, we have to add this dependency. We are using another one as well, that is deflate. Deflate by default comes with the AVRO package. Let us look into the code. Code is similar. Here the method is changed to accept a compression algorithm name as well. Depending on that one, it will compress the file. The extra line that we added here is which type of compression to be used. In the data file writer, we are saying set codec and codec factory dot snappy codec if we have passed snappy. Deflate, if it's a deflate string is passed. Deflate takes an integer value from 0 to 9. We are giving the maximum, that's a 9. Then this is by default. To show the compression, we are adding 1000 records to the file. Rest everything is same as what we have seen so far. Let us run this file. This is previously created. This is the uncompressed file. This is snappy compressed, and this is deflate compressed. See the difference. Uncompressed file is 82 KB. Snappy compressed is only 5 KB, and deflate is only 2 KB. That means it is doing heavy compression. So Snappy is a little bit less than the deflate, but still people use Snappy because Snappy is very fast in compressing the data. Let us open one of the record here. Here itself we can see which conversion algorithm is used. Here you can see that it's the Snappy is used. I think you have got an idea of how AVRO file is structured and how to create or read or write AVRO files using Java.